Ever felt like you've mastered one aspect of coding, only to be blindsided by another? That was me. I aced JavaScript, felt on top of the world, then crashed hard on data structures and algorithms. This is my story, and how I learned that true developer strength lies beyond just language syntax. Hello everyone, and welcome to my channel. Today I'm going to share a deeply personal and, frankly, humbling experience from my journey as a developer. It's a story I believe many of you, especially those early in your coding careers, might relate to. The shock of realizing that mastering a programming language doesn't automatically mean you're ready for everything the tech world throws at you. I had spent months, even a year, immersed in JavaScript. I built projects, understood frameworks, and felt genuinely confident. I thought I was ready for any technical challenge, especially those involving coding. Then came the interview that changed everything. It wasn't about writing a component in React or understanding asynchronous operations. It was about optimizing a solution, thinking about efficiency, and choosing the right data structure. I stumbled, I fumbled, and ultimately, I failed. It was a stark reminder that I was missing a crucial piece of the puzzle. Let's rewind a bit to where my confidence was soaring. My journey with JavaScript began like many others. I was drawn to its versatility, its ability to bring web applications to life, and the vast ecosystem of libraries and frameworks available. I delved deep into the language, learning everything from basic syntax and DOM manipulation to advanced concepts like closures, prototypes, and asynchronous programming. I built several full-stack projects using Node, JS, Express, and React, feeling increasingly proficient with each line of code. After months of dedicated learning and building, I genuinely felt competent. I could debug complex issues, design clean architectures, and translate ideas into functional code. I believed I was ready for technical interviews, confident that my JavaScript skills would carry me through. But then came the interview that shattered my illusion of preparedness. It was for a dream role, and I walked in feeling good, ready to showcase my JavaScript prowess. The first few questions were about the language itself, and I nailed them. Then, the real challenge began. The interviewer presented a problem. It wasn't about how to write a loop in JavaScript, but how to solve a problem with optimal time and space complexity. They didn't just want code, they wanted an efficient solution. I froze. My mind, so adept at JavaScript syntax, struggled to grasp the underlying algorithmic principles needed. It became clear that my JavaScript knowledge, while strong, was akin to knowing how to drive a car perfectly without understanding the mechanics under the hood. I could make it go, but I couldn't diagnose or fix deeper issues, especially when it came to performance and scalability. I realized then that my strong grasp of JavaScript wasn't enough to pass a data structures and algorithms interview. This experience forced me to confront a fundamental truth about software development. Knowing a language is one thing. Understanding how to build efficient, scalable, and robust solutions is another. This is where data structures and algorithms come into play. DSA isn't just about memorizing algorithms. It's about understanding how to choose the right tools for the job. It's about efficiency, how much time and space your code takes to run. This is often explained using Big O notation, which helps us compare the performance of different algorithms as input size grows. It's critical for writing performant applications. It's about solving complex problems, not just writing code. It's about being able to break down a large problem into smaller, manageable parts, and then designing an optimal solution using appropriate data structures like arrays, linked lists, trees, or graphs, and algorithms like sorting, searching, or dynamic programming. After that humbling interview, I knew I had a significant gap in my knowledge. I decided to tackle DSA head-on, treating it with the same dedication I had given to JavaScript. I started by researching the best resources. I enrolled in online courses specifically focused on DSA, bought classic textbooks, and, most importantly, I dedicated hours to platforms like LeetCode. LeetCode was a game-changer, providing endless practice problems that forced me to apply theoretical knowledge to real-world scenarios. The key was to break down complex topics into digestible chunks. I started with fundamental data structures like arrays and objects, then moved to more complex ones like hash tables, linked lists, and trees. For algorithms, I began with simple sorts and searches before tackling recursion, dynamic programming, and graph algorithms. Consistency was crucial. Even 30 minutes a day made a huge difference. One of the most valuable insights I gained was how to bridge my strong JavaScript knowledge with these new DSA concepts. It wasn't about learning a new language. It was about understanding how these fundamental computer science principles manifest within JavaScript. I learned to implement common data structures like stacks, queues, and linked lists using JavaScript objects and arrays. I practiced writing sorting algorithms like bubble sort, merge sort, and quicksort from scratch in JavaScript, paying close attention to their time and space complexity. For example, consider searching for an element in a large array. A simple linear search might work for small arrays, but for larger ones, it becomes inefficient. By applying a binary search algorithm, which relies on the array being sorted, we can drastically reduce the search time, making our JavaScript code much more performant. This optimization thinking is what DSA teaches you. My journey from acing JavaScript to flunking DSA and then conquering it has been transformative. It taught me that being a truly competent developer means having a deep understanding of not just the language you use, but also the underlying principles of how efficient software is built. It's about problem-solving, optimization, and continuous learning. I hope my story inspires you to explore DSA no matter where you are in your coding journey. Thank you for watching.